Hello. So this recording is going to be showing the solutions to factoring linear expressions, the YouTries from the YouTube video. So some of them, most of them, I'm just gonna breeze through them. I am going to go more into detail for number 3 and number 8. I will be putting time codes in the description box. So if there are specific problems that you would like to see, I will be putting the time codes for that in the description so you can just jump to them. So let me just get started. So the point of the YouTries were to practice factoring expressions. So yes, I do know 18 minus 12 is 6. But the reason why he only gave you numbers was so that you could practice without any variables in them. Because sometimes when you add variables, it gets a little more confusing. You think it's more complicated. So that's why we started out with just numbers. Okay. So if you were to find the GCF of 18 and 12, writing out the factors for these is quite easy because they're rather small numbers. Okay, so 1, 12, 2, 6, 3, 4, and I'm pretty sure that's it. 18 is 1, 2, 18, 9, 3, and 6. Is that it? Yep. Okay. So you know when to stop here once you go up to a certain point. So 1 is 18, 2 is 9, and then 3 is 6, 4 doesn't work, 5 doesn't work, then you move up to 6. Once you get to a number that's already on your list, you know that you've covered all the factors. So if you start from 1, then you keep going up. But that sometimes that takes too long, and that's why I don't really like that way. But we can see here, greatest common factor, 6. Okay, so GCF is 6. Oops, sorry, I meant 6, not 16. Okay, so we have here, this is equal to 6 times 3 minus 6 times 12, 6 times 2. Okay, we're going to take these factors out because they're the same. Okay, we're going to move these factors out. And if you can see, it's kind of like the opposite of distributing. Okay, I'm going to take them all out. And then I'm going to keep the ones that were not the same in the same place. So we got that 3 minus 2 there. That's our final answer. Okay. So that was number 1. Number 2. This one I'm not going to talk so much. I'm just going to do it. 60 plus 36. Okay. 60, 36. I can already tell that they have 6's in common, but It might have more than just 6 in common. I'm going to write out the prime factorization. Okay, so 60 is going to be 2 times 2 times 3 times 5. 36 is going to be 2 times 2 times 3 times 3. And doing these little things like organizing as you go, putting these numbers in order, that's an important skill to have, not just in math, but you got to clean while you cook. Otherwise, you're going to have a bunch of dishes to wash at the end. And that is annoying. I would know. Okay, so our GCF is going to be 2 times 2 times 3, which is 4 times 3, which is 12. Okay, see, so 6 is not the greatest common factor. 12 is the greatest common factor. 12 is a multiple of 6, so 6 is part of it, but it's not the greatest common factor. That's why I like using prime factorization. So let's rewrite this. This is 12 times what is 60? 12 times 5. And then 36 is 12 times 3. Okay, we're gonna factor them out to get 12 times the quantity 5 plus 3. That's our final answer. Okay, so since I kind of already talked about number 2, that's the same issue that we ran into for number 3. Number 3, oh my God, what just happened? Oh, something happened. Okay. Number 3, 100 minus 80. Sorry, I just added those parentheses in there because writing parentheses is a habit. Okay, so we got 100 minus 8. And a lot of people said, 8, I know. They have 10 in common. 10 is the greatest common factor. Nah, I can think of a bigger common factor. I can think 20. Is 20 the big? Oh, maybe 20 is the greatest common factor. So 100 is 20 times 5. 80 is 20 times 4. Okay, 5 and 4 don't have anything in common. So I know 20 is indeed the greatest common factor. Okay. So if it were 10 times 10 and 10 times 8, well, I know 10 is not the greatest common factor because we see here, right here, 10 and 8, they still have something in common. They have a factor of 2 in common because they're both even. That's why 10 is not the greatest common factor. The greatest common factor is going to be 20. So let's write that again. 20 times 5 minus 20 times 4. And we get 20 pulling all that out. Times the quantity, 5 minus 4. Their final answer. Okay, then we double check. Did we factor it correctly? 5 minus 4, that's going to be 1 times 20. That's 20. 100 minus 80, 20. So we factored it correctly. So the issue that I had while commenting on your assignments wasn't the fact that you were factoring incorrectly. In fact, many of you factored it correctly. It's just that you didn't factor it all the way. That's it. Okay, number 4. 48 plus 72. Okay, greatest common factor. I don't use these numbers quite as often, so greatest common factor is not off the top of my head. But I do know my times tables pretty well, so I know 48 is 6 times 8. 2 and 4. 2 and 2. Okay, 72. That's 8 times 9. So that's why being good at your times tables can really help you out. Because when you see 72, you just think, 8 times 9. And of course, yeah, math is not really about memorization. But memorizing something is just trying to help you make it easier so that things are just quick on the recall. It's like if you play an instrument, you play it so much, you play that piece so much that you've memorized it. And then it's just really easy to play because you don't have to think about reading the music. You just play it. It's amazing. Okay, circling the ones that we have in common. I've got 3 2s in common. There's an extra 2 here, not in 72. I'm not circling that too. Okay, and then we got 1 3 in common. Okay, so the GCF is 2 times 2 times 2 times 3. 2 times 2 times 2. I know that's 8 times 3, which is 24. Okay. So, let's see. That's 24 times. I know that 48 is going to be 24 times 2 because guess what's left over from what we didn't circle from the 48? A 2. So that's going to be 24 times 2. See, then with the prime factorization, it's just easy for you to figure out what the other number is going to be because it's just what's left over. You don't actually have to divide anything. You don't have to say, hey, what's 48 divided by 24? No, you just know because that's what's left over. Same thing with 72. 3 is left over, so that's why I know. Okay. So I'm going to bring them out. 24. That's in common. So I'm going to say that's 24 times the quantity. 2 plus 3. Okay. Number 5. So now we're getting into the expressions that are actually linear expressions, the ones with the variables. So what's a linear expression? You guys remember? Linear expression is an expression whose variable does not have an exponent. So this is not x squared. Okay. So do we have to factor anything out for the variables? Do they have any variables in common? 15x, the first term, 15x. Who's got an x in it? The second term, 6. It's just 6. There's no letter. So don't worry about the letter. They don't have it in common. They're just going to stay, the x is just going to stay where it is. But we are going to find out what is in common between 15 and 6. 15 is 3 times 5. 6 is 3 times 2. And so the reason why I'm putting it in this order when I write it down is so that it's very clear that 3 is the one that's common and the one that we're going to pull out. So our greatest common factor is 3. This is the same thing as 3 times 5. That gets us 15. And then we still have this times x here. So we just leave it. Don't do anything with it. Leave it there. 3 times 5, that's going to get us 15, times x, that's going to get us 15x. Minus 3 times, you know it, 2. So same thing as the first 4 problems. I'm just going to bring those out. And I'm going to get 3 times the quantity, 5x minus 2. Okay, number 6. 9 plus 36w. Okay, and a lot of people immediately recognize that 9 is the greatest common factor. So, pat yourself on the back. Okay, 9 is indeed the greatest common factor. But when we pull out 9, we can't just leave it blank. 9 times what is 9? 9 times 1. That gets us 9. Okay. That's why we're rewriting it. So that it's clear to us what should be left behind. 9 times what is 36? 9 times 4 is 36. We leave the w there because it's multiplication. Okay. 9 times 4, that gets us 36, times w gets us 36w. Okay, so let's bring those out. And we get 9 times the quantity, 1 plus 4w. If you want to be a real stickler for stuff, we do like to have the variables come first in an expression. So you could rewrite this as 9 times the quantity, 4w plus 1. That's just a convention that people like to follow. And you'll find that they do that just to make their lives a little easier, you know? Like I said about cleaning as you go, you organize as you go so that you don't have a big mess at the end. Okay, number 7. 27x minus 18y. Do they have any variables in common? The first term and the second term. The first term, 27x. Oh, has an x. The second term, 18y. Does it have an x? No, it has a y. So they don't have any variables in common. So don't worry about it. But we are gonna find out what 27 and 18 have in common. 27 and 18, both multiples of 3. Yes, that is true. They are also multiples of 9. Okay. So 9 is our greatest common factor. Let's circle that. GCF is 9. Okay, let's rewrite. 9 times 20. And a lot of you guys did really good on this part. You guys rewrote it. You guys did a good job. Okay, we're going to pull those out. So we're going to get 9 times the quantity, 3x minus 2y. So we're going to keep doing practice with this because practice is good. This is tough stuff. I mean, you guys being forced to basically learn on your own. That's tough. But you guys are doing good. I'm gonna try to keep up with, everything that's going on as well. So I'm sorry if I've been responding to you very slowly. Okay, number 8. This one threw a lot of people off. And this one was for sure the most challenging one because this is not a linear expression. It's a non-linear expression. Yes, he threw it in there to throw you off. But it's really just the same thing. Do they have any variables in common? One's got an x, one's got a y. Do they both have x? No. Do they both have y? No. So do you need to worry about the variables? No. Just because it's got a squared in it just means it's x times x. There's 2 x's that you're multiplying together, not adding together, that you're multiplying together. So x times x. It doesn't really mean anything. Okay, so same thing as before. We're going to find the greatest common factor between what we can find in common, 10 and 35. I already know. 10 is 2 times 5. 35 is 5 times 7. And I see they've both got 5. G, C, F. Okay. So rewrite, rewrite. 5. So we're just rewriting the same thing that looks different. It's still going to be 10x squared. It just looks different. We're just making it a little longer is all. 5 times 2x squared. Okay, we're going to multiply what we can multiply. We can multiply the 5 times the 2. That gets us 10. 10x squared. 10x squared. So we kept the things the same. It just looks a little different. Don't worry about it too much. Okay, so we're going to rewrite this one. 5 times the quantity. 5 times what is 35? Oh, 5 times 7. 5 times 7. Then we just leave the y there. Yeah. You need to know the why. Sometimes you really don't need to know why it works in order to do something. Of course, it's always a good thing to know why it works, but sometimes, it's just a matter of survival. You got to figure out how to do it and then worry about why later. Okay, so the final answer is 5 times the quantity 2x squared plus y. So I will be posting all of these onto YouTube, of course. I will also be putting it into Google Classroom. And remember, I want your feedback about my videos. If it helped you, if it made things clear for you, I would like to know. If things were confusing, I would like to know specifically which part, because if I don't know which part confuses you, I don't know where to begin to start helping you. So help me help you. Please give me feedback on these videos because I want to make things that are useful for you. Okay. So thank you for watching, and I will see you next time.